Hello and welcome to the Storage, Flash, NVMe, and Storage Optimization EcoCast event. Today is Thursday, February 7th, 2019, and my name is David Davis from Actual Tech Media. Today's event is produced by Actual Tech Media, and I'm excited to be welcoming presenters today from DriveScale and Western Digital. We'll also have a special keynote from Actual Tech Media CEO, Mr. Scott D. Lowe. So the format of today's event, if you haven't joined us before, is that each of the presenters will speak for roughly 20 minutes, followed by a live 3 to 5 minute Q&A session. During that session, I'll be asking the best questions from you out there in our audience. So thank you for your questions in advance. This event is not a competition between the presenters. There's no winner being selected here today. Again, this is an educational event. Before we jump into it, we've got a little bit of housekeeping to cover. First off, prizes. We've got some really cool prizes. I'll talk about those prizes and exactly how to be eligible for the prize drawings in just a moment. Next up, questions. We'll be asking you a number of questions during the event. These poll questions are for your benefit as well as ours. We want to help to make future events as useful and relevant to you as possible. So we're very interested in your answers. And I'll be sharing the answers to most of the poll questions with you so you can see how you stack up with those out there in the audience. We also encourage you to ask questions. As I said, I'll be taking the best questions during the live Q&A sessions with each of our presenters. So use that questions and answers box as much as you'd like. We'll be trying to respond to every question as they come in, and I'll be queuing up the product-specific questions or technology questions for each of the presenters. We also want this to be a social event, so we encourage you to promote this event on Twitter. You can do that with today's hashtag. I'll be reminding you of that hashtag in just a minute. You should know I'll be monitoring the hashtag throughout the event over on Twitter. I'll be retweeting your posts and following just about anyone who posts using the hashtag. And then finally, we have a number of resources or handouts selected. You can click on the Handouts tab, which is right next to the Questions and Answers tab on your audience console. If you click on each one of those handouts, you'll download the corresponding PDF asset, or you'll be taken to the website that's been provided by today's presenter. So make sure that you check out those handouts. You should know that your audience console that you're viewing there in your web browser is kind of like a windowed operating system where you can drag, maximize, minimize, and resize all of the windows that you see there. In fact, I encourage you to make the slides window as large as possible so that when today's presenters play videos or they show architectural diagrams or do screen shares, you can see those as large as possible in your web browser. If at any point during the presentation you have trouble, simply press refresh on your browser, and 9 times out of 10 that will resolve any technical problem that comes up. If a refresh does not resolve it, in many cases you can simply try another web browser, and most of the time that will resolve it. If it doesn't, send us a question in the questions and answers area. Now, just a reminder, this is a completely live event. Things can and sometimes do go wrong on live events. So if there is a problem, I ask in advance that you please be patient with us. We have presenters calling in from around the United States and in some cases around the world. But it is my expectation that this will be a perfect event today. For today's prize drawings, we are giving out 3 Amazon $500 gift cards. So make sure you stay tuned throughout the event because we'll be announcing the winners of these gift cards after each presentation. Now, to be eligible for today's prize drawings, you must be present on the live event. We do the drawings multiple times throughout the event. Winners have the option to make a donation to a selected charity. Grand prize winners must submit an IRS Form W-9 to Actual Tech Media. We will reach out to prize winners via email after the event, and the full prize terms and conditions can be found on our website, as well as on the Handouts tab right there in your web browser. If you click on Handouts and scroll to the bottom, that's where you'll find the terms and conditions link. Now, through the MegaCast and EcoCast event series, thanks to generous prize winners, we have given out thousands of dollars to the selected charities that you see on the screen here. So if you win one of these prizes and you say, you know what, I just like to help someone less fortunate than me, we can donate that prize value in your name to one of the selected charities. So thank you in advance if you should choose to do that. Now, I know I said I want this to be a social event, so the hashtag for today on Twitter is Storage EcoCast. I'll be tweeting about the event using that hashtag, and I encourage you to do that as well. Hopefully, if you have something nice to say. Today's event is produced by Actual Tech Media. You can follow us on Twitter as Actual Tech Media. Also follow me on Twitter, where I am David M. Davis. And with that, I'm excited to introduce our keynote presenter. That is Mr. Scott Lowe. Take it away, Scott.
Hello, and thank you for joining us for Actual Tech Media's first storage event of 2019. For this event, I'm going to kick it off, or have included in it, a storage market snapshot. This is a 2019 edition and provides some overview of some things you might want to know as you consider storage projects in 2019. My name is Scott Lowe. I'm the CEO and lead analyst of Actual Tech Media, and I'm very happy to be here today to talk about the storage market and what's happening. So let's look at some facts. What's happening in the world of storage today that may not have been happening just a few years ago, or may have been happening in some cases? You know, one of the things that's really interesting right now is we're seeing increasing silos of storage when it comes to enterprise IT. We're seeing, cloud-based storage repositories, primary storage systems, a sprawling of secondary storage systems, and also hyperconverged infrastructure systems that are helping to reshape the storage market. Now, it's important for organizations to really look at all of these things as they look at their storage plans to see what makes sense. But we're going to continue on for now before I make too much in the way of advice. When it comes to media, all flash continues its rise. And that makes sense because if you look at flash, it's obviously a far more performant storage media than we see from, legacy disk. That's a very clear thing. NVMe today is also on the scene. We'll be talking more about NVMe shortly in this presentation, but it's something that as organizations seek to improve overall workload and application performance really should be a part of their storage strategy. NVMe storage is on the market, it's affordable, and it can do some pretty incredible things when it comes to improving the overall speed of storage and reducing latency in the storage equation. We're also seeing really this multi-cloud stuff happening today, and that includes storage. If we look at a lot of storage solutions that are on the market today, it's clear that organizations need to be looking at solutions that can help them do everything from on-premises to the cloud and everything in between. And that's really important to look at this from a fabric perspective. What's going to overlay the whole thing to make sure that we have a consistent storage experience from soup to nuts? And that's something where, as we look at multi-cloud storage for the likes of, Amazon, Azure, and a number of other players, combined with the private cloud storage that we have, it's really important that all this stuff works together from a strategy perspective. And obviously, as we look at different storage types, file, it's not really media, but it's a storage type. File, block, and object storage all continue to have their unique traits that serve different needs. And organizations need to have a strategy around each one of things. And if we look at file storage, for example, then we had that forever. That's file servers and things like that. NFS and all that good stuff. As we look at block storage, that's commonly used in virtual environments and by lots of application servers. Object storage is used when we need to have mass amounts of data that's well structured that we can get at for all kinds of purposes. It's really important to understand some of the key data characteristics that we're seeing really shaping the market. It's a number of V's. The data volume, the data velocity, the data variety, and the data value are all things that organizations really need to consider as they look at their ongoing storage plans. Data volume is clearly about capacity. This is basically how much am I storing and how much am I going to have to store in the future. There's all kinds of statistics out there that tell us that by 2022 we're going to have hundreds of zettabytes of storage being created, and we have to be able to have ways to manage that onslaught. Now, that doesn't mean every enterprise IT organization is going to see a zettabyte of storage hitting their data center, but they're going to have to be prepared for data volume from lots of different places, and I'll talk about those shortly. And then we talk about the velocity of data. And this is not a way we always term things, but data velocity really is a discussion about how quickly we have to ingest data into a system. And as we look at real-time storage needs, and we are really getting to a place where real-time is critical for certain applications. Think about an autonomous vehicle, for example. Latency in the storage equation in an autonomous vehicle could make the difference between the car, running into a person or the car making the decision to stop. So these sorts of discussions are really important when it comes to, how quickly we're ingesting data. Now, the typical enterprise IT organization isn't going to have that kind of life or death scenario in front of it all the time. But it still has to think about how quickly data has to be ingested And that's going to contribute also overall to a data volume discussion. And then we have the data variety. As we look at the sources of data from things like Internet of Things connected devices, from our mobile devices, from all over the place, there's an emerging need to make sure that we're better understanding the kinds of data that we're storing in our environment. And this kind of thing is going to be more important as we look at meeting the more stringent compliance requirements that we see entering the realm, the sphere of what we have to deal with. Things like GDPR and other compliance structures are going to require us to understand what we're storing, and that is a variety question. What are we storing? How are we storing it? And then the question of value comes into play, and this is the why. Why are we storing data? And when we look at the overall data picture, the value of data really can't be underestimated. We've seen some companies describe data as the new oil, or data is gold, or data is the lifeblood of the organization. The value of data is increasing every year. And if we look at just the news, what's happening with companies like Facebook and Google and the like, the value of the data that those organizations are capturing and storing is incredible. Facebook has a value per user based on the data that we provide them. Now, again, not the typical enterprise is not necessarily Facebook, but the value of data to the typical enterprise is also incredibly important. We're actually seeing on the market today, companies that are rising up to harness all of an organization's various data assets in an attempt to help organizations better understand their customers. And that's something that, and we've seen those for years, but they're getting much more mature and much more capable today as it becomes possible to really aggregate data from lots of different sources. So the value of data is something that we can't underestimate over time. What are some of the drivers around really a lot of the things we're seeing in the data characteristics area? One is just general operations. Every day we're processing transactions, we're helping customers, we're creating incident tickets and things like that. And those are general operations that we have to store the data for so we can do something with it later on. And whether that is address the problem for a help desk ticket, or roll up a sales order database into an analytics platform, whatever that happens to be, general operations really covers that. Then we have the Internet of Things, and this is sometimes an overhyped phrase, but it's a real thing. If you look at companies that are providing these sorts of services, look at Nest or Alexa, or just some of the simple things like that. There's a lot more, especially as you get into the industrial realm. There's all kinds of data being generated by these devices and the sensors that power these devices, and that's something that we have to think about when it comes to overall data volume, and it also becomes a data velocity issue as well, because sometimes these sensors can be providing data at a pretty insane speed. Then we look at artificial intelligence and machine learning. Now, we have to have, for organizations that are going to undertake projects around AI and ML, there's incredibly huge data sets necessary to really train their models. And that has to be generated from somewhere, purchased from somewhere, or some other mechanism by which we get that data. But it's critical, and it's really important, and we have to make sure that we have a place to store that data and use it in a way that allows us to train these algorithms. And that really comes down also on a performance side. If it's not fast enough, it's going to take a long time to train the models. And so there's a lot of things that go into understanding what we have to, the characteristics that are necessary for an AI or ML project to be successful. Then there's augmented reality and virtual reality. Those are pretty self-explanatory. There's lots of data there. But also, this goes along with IoT a little bit, but the notion of the edge. Edge computing is a relatively, somewhat new term that describes a location that's not the cloud and not the data center, but where we see a lot of work happening. The edge can be a remote office or a branch office, for example, something as simple as that. The edge could be an autonomous vehicle, for example. There's lots of things we can use to describe the edge, but it's a place where a lot of data is being generated and a lot of data is being manipulated and handled, and it's something that storage administrators have to account for in their plans moving forward. As we look at the role of storage in the organization, it really has there's other things that are impacting it. As we look at architecture overall, data center architecture, there's a lot of things that are impacting what's happening in the data center. And it's important for us to understand that. We see an evolving of IT operations. This idea of doing more with less or simplifying IT operations is really, really catching on in a big way. And it's for a lot of reasons. We're not going to just continue to add lots and lots of IT people, but there's a need to make sure that the IT function is maximizing its contribution to the business. And that means that IT can't constantly be in the weeds. And that means that some of the basic storage operations we may have undertaken in the past are things that we can't really afford to do anymore. So we have to find ways to help make sure that our storage environment better matches the evolution of IT operations to match the needs of the business. There's also an intense focus on security. And organizations are significantly increasing their spend on security, sometimes to the detriment of other areas of IT. And that might mean that the storage budget takes a hit, or other areas of the budget take a hit. But it's another way that we're evolving IT operations to better meet the needs of the business when you really think about it. Because security is becoming a paramount concern in a world that's increasingly interconnected and where there's additional risk that organizations have to deal with, whether they like it or not. And that also comes down to compliance. When we think about some of the things I mentioned before, like GDPR and lots of other compliance frameworks, we have to understand where data is, and we don't always know that today. So we have to have storage systems that are a little bit smarter, that can help us understand what we're actually storing, but also we have to have just simply enough storage to deal with it all. And it's somewhat overused, but the digital transformation trend is something we have to think about as well. And it really comes back to evolving IT operations, and it means that we may have to change the way we manage some underlying architecture elements, including storage. There's going to be a focus, and there is a focus from the business and from the organization itself to undertake these efforts to harness technology to improve the customer experience in some way. And that means that we can't constantly be in the weeds. We have to be thinking about this from a very high level, and that may mean that we can't be as hands-on as we used to be in the past. And what does it all mean? It really means that there's a need to potentially massively shift the storage architecture. We may need to think about buying new systems that can grow bigger, can go faster, that can be easily recombine resources to create new workloads, which we'll talk about shortly. But there's just a need to really rethink the entire storage paradigm and make sure that we have a solution in place that allows the most flexibility for the business. And we have to look at storage from a fabric perspective. And what I mean by that is, from the edge to the data center to the cloud, we really want to look at a common platform that can help us in all three of those areas. And that may not, really pertain to every organization or be applicable to every organization, but it's something that I think, especially larger organizations, really need to be taking a look at. And it goes back to how we evolve and simplify IT operations. The more that we can have a common architecture that spans cloud to data center to edge, the easier the operations are, because there's less to learn, there's less to deal with, and there's less difference between those platforms. So that's why I think about this from a fabric perspective that sort of overlays the entire environment. And it all comes back to a renewed need for simplification to enable better focus on business needs. And I don't think that's something we can overstate. That's a critical need that's always been there. But as we see organizations really striving to move forward, it's going to take on a renewed focus. So when we think about storage, pros and decision makers, points of focus, what are some things you need to do this year to make sure that your storage environment is where it needs to be? First of all, you should keep considering and adopting flash. That just doesn't, there's no way you can stop adopting flash, especially as prices continue to drop. A couple of years ago, we saw prices of flash seriously increasing due to resource constraints and manufacturing constraints. But over the last year, that's really started to change, and that's changed in 2018, and it's a change that's continuing into 2019, where the price of flash is dropping pretty dramatically and becoming more affordable for more organizations. So we really should be looking at flash. And in concert with flash, we don't want to have these old, spinning disk appendages still laying around. So we should be looking at NVMe storage systems where we can and where it makes sense. Not every organization needs it, but where it makes sense. to help improve overall workload performance and enable better scaling capability. And we also need to look at what are we calling composable technologies, which I'll talk briefly about shortly in this presentation, that help us to enable granular resource combinations and scaling capabilities. And we're going to talk more about that shortly. But from a directly actionable, what you should walk away from this presentation, realizing is that we need to really look at our storage environments and look for opportunities for improvement. Where are areas that I have potential weakness, or where I have potential inefficiency, or where I have potential unnecessary cost, and how can I look at addressing that from a holistic perspective from the cloud to the data center to the edge? And one of the things that has become very apparent in the last decade is you're going to never stop evaluating storage solutions. This is a market that is dramatically shifting and has shifted over the past decade, and it's one of the areas that's going to continue to undergo the most change. So you need to be continually scanning the market to make sure that what you're operating makes the most sense for your organization on an ongoing basis. Now let's talk about NVMe a little bit. Let's go a little deeper. So I'm not going to go into great detail here because there's tons of resources out on the internet about this, but I think it's a topic that's worthy of quick discussion. Really what NVMe does is it brings flash into the present. And what I mean by that is if you think about our original flash systems, they really were hindered or hampered by some of the elements, the vestigial elements that they had from the spinning disk days, namely SAS and SATA. Those were protocols that were developed for spinning disk, and they worked just fine for spinning disk because of the way the spinning disk operated. But NVMe replaces the SAS and SATA interconnect and more with a modern protocol stack that best matches the characteristics of solid-state storage. For example, it replaces a single command queue with 65,000 command queues. And why is that important? If we think about spinning disk, when a single command queue made sense because we could only read and write one data element at a time. The reader write head would go to the appropriate location on the disk, be read, be processed, and moved to the host. And that was a serial operation. And you could not have multiple heads reading the disk at the same time. Well, the very nature of flash means that we can address cells of flash at the same time. So by replacing the single queue with 65,000, we can all of a sudden address far more disk capacity or elements of the disk than we could in the past. And think of it as a straw. So, with SAS and SATA, we had a little straw that we would, try to drain a swimming pool, for example. And you could get a bigger straw, you could get faster SAS connections and things like that, faster SATA connections, but you still only had the one straw. Now imagine if you had 65,000 really big straws and 65,000 people pulling water through those straws. You could much more quickly drain that pool than you're going to be able to do with a single straw, no matter almost how big it is. So it makes sense that having lots of queues to help us, manage our storage is going to be a lot better than having just one. And if we look at the queue depth, basically the number of commands that we can store in a queue, SAS had a queue depth of 254 commands, which means it would stack up to 254 commands that for serial processing. And SATA had a queue depth of 32, which means we could stack up to 32 commands for serial processing. And if we look at NVMe, we have a 65,000 command queue that can happen much more quickly than it could happen, that we can be addressed much more quickly than it can happen with SAS and SATA. So we have 65,000 queues, each that can store 65,000 commands. So we have tremendous capacity in NVMe that SAS and SATA with hard drives are simply never going to match. And this is one of the reasons why NVMe data path from start to finish can be a powerful enabler for improving workload performance. It really brings out the full capabilities of modern solid-state storage in a way that we're never going to see from SAS and SATA devices. Now let's go a little deeper as our final topic into composable infrastructure. And this is not just a storage discussion at this point, because composable can encompass storage, but also compute and networking resources. And it's really the next iteration of the software-defined data center. Some people look at it as sort of a step beyond hyperconverged in some ways. But it can include any combination of compute, storage, and networking. It doesn't have to include all three of those. Sometimes we'll see composable solutions that include just compute and storage. But it treats those those resource elements a little bit differently than we see from other solutions. And this is going to sort of be one of those round robin things. Resources are composed and recomposed on the fly as workload needs dictate. What does that mean? Basically, we are abstracting all of these resources, just like we do in the software-defined data center. If you look at software-defined storage, or software-defined networking, or software-defined servers such as virtual machines, with the phrase we've always used is abstract, pool, automate. We abstract the resources from the underlying hardware. We pool those resources so they can be used, and we wrap some automation layer around them so that we can manage them. Well, when we think about composable infrastructure, we're doing this with a whole bunch of resources at once from across a whole bunch of hosts at once. And so we're able to bring networking resources from the underlying hosts, storage resources from the underlying hosts, and CPU resources, and build them in a way that's far more flexible than we have seen in the past. So this enables a really high degree of resource flexibility that we may not have been able to achieve in the past. And it provides an environment that can help us adhere to workload performance requirements. So we can pull together resources that include flash and spinning disks. So we may have an application that has some performance requirements and then has also some capacity requirements. And so we can pull together, the system can pull together as it sees fit, those resources to make sure that workloads operate the way we would expect. And this can help us reduce overall infrastructure costs because we can get far more granular with how our resources are configured than we can with other solutions, while also improving overall operational efficiency because our workloads can be faster and more performant, but also we don't have to, as administrators, get as deeply involved in composing the workload operating environment for each individual application. The system can help pull these things together on its own based on what it's seen happening in the environment. And that is the end of my presentation today. I thank you for watching, and I hope you enjoy the rest of our event.
And with that, I'm excited to introduce the first presenter on today's Storage EcoCast event. That is Denise Schiffman. She is the Chief Product Officer at DriveScale. Denise, are you with us?
I am, David. Thank you for having me here.
Yeah, thanks for being on. Take it away.
I will. Thank you so much. Hello, everyone. I am Denise Schiffman, Chief Product Officer at DriveScale, and it's great to be a part of Actual Tech Media's NVMe webinar to talk to you guys about NVMe Flash and true composable infrastructure. DriveScale is the only company in the industry providing a comprehensive composable solution as software that composes heterogeneous, low-cost hardware, including NVMe storage. I'm also really happy to be sharing this webinar with our fantastic partner, Western Digital. Some of you may not be familiar with composable infrastructure, so I'll begin with the transformation we're seeing happen in IT, and that is the rise of data-intensive computing, which starts with all of the data-intensive applications, including everything from NoSQL and massively parallel processing databases to Hadoop and machine learning, as well as these massive object storage facilities, object stores, and tiered storage. And as was mentioned earlier, this all-flash. NVMe, solid-state storage, is needed in a lot of these data-intensive applications. And it's interesting what's happening in the investment that's going on around analytics and data-intensive computing today. And that's because companies have the ability to use analytics and advanced analytics to inform their business strategy, streamline operations, identify fraud, and engage in real time with customers to essentially impact the growth of the company. And it doesn't really matter whether it's a cloud-native company or an enterprise across pretty much any industry. And McKinsey states that machine learning and deep learning and other advanced analytics will unlock up to $15 trillion in value annually across all of these industries. And that's why there's so much investment going on. And so to unlock this value, IT teams are processing, analyzing, and storing more and more data and need to find seamlessly scalable and cost-effective solutions for both computing and storage. And trying to do that with today's technology can be a bit of a challenge. Modern data-intensive applications are more dynamic and less predictable than traditional back-office applications, such as an ERP or Windows Exchange server or even an Oracle database. And I think what's really interesting is this growth of data IDC predicts to be 5 times growth in the next 5 or 6 years to 175 trillion gigabytes in a year is really having an impact and causing new stresses in IT and operations, not only from the cost, but how we manage this growing and changing infrastructure. The unpredictable nature of these dynamic applications creates new stress on the infrastructure. We need to think a little differently about how we deploy compute infrastructure. We need to think about things like workload performance. Is it a performance-oriented or latency-sensitive application? Is a workload run daily or once a month or continuously? Will the data continue to grow, and at what rate? And is the data streaming in and being computed on in real time? This mix of attributes, which can be different for each workload, makes planning for the capacity requirements as well as the performance requirements of the workload a great deal more complex. And then when we look at this data growth, we need to look at how we're going to manage the cost of storing this data and computing on this data. And then as our environments scale, how do we maintain the performance that we've spent all this money investing in? And so those are some key things we need to figure out how to do. And what's happening today with traditional infrastructure is most of us are over-provisioning our infrastructure and leaving stranded resources. Since, as I said, most data-intensive applications are deployed on direct attached storage inside the server, or what we call DAS. These DAS servers are pre-configured fixed SKUs. And since the compute and storage is trapped inside the box, you often see stranded resources in enormous ways. In fact, you see server SKU sprawl, cluster sprawl. You have specific SKUs used for a specific cluster, so then each application that runs requires a different server SKU, so that cluster is different. And then the management and operations of all of that different hardware has a cost associated with it. Servers often can't be redeployed after a workload completes because the configuration doesn't fit the next workload. And while many applications require the performance of the latest CPU, more than 40% of spend is wasted upgrading drives at the same time because, once again, what you buy is that pre-configured fixed SKU. And so because it is more difficult to plan, meaning figure out what capacity of compute you're going to need, what capacity of storage you're going to need for a specific workload, a lot of time is wasted trying to determine, and then in the end, over-provisioning is done. And lastly, it's difficult to increase rack densities and reduce data center footprint with these traditional DAS servers. And lots of companies are faced with needing more data center space. Deployments are often inefficient and slow to deploy and result in wasted spend. And when we look at NVMe, this problem is exacerbated. There are many, many performance-hungry apps that demand NVMe flash storage. This includes everything from IoT streaming to fraud detection to machine learning-based applications. And NVMe, with its parallel interface and deep and wide queues, provides significant reductions in latency and significant increases in I/O performance per RU. And in addition, NVMe was designed for current day flash, and we're going to talk a little bit more about that. But what we don't want to see is firmware in the drives and duplicated data management in the storage systems, which actually bog down the performance that you've actually paid for. Since the data-intensive applications have the data duplication and data management, snapshots and backup already incorporated in them, you don't want to replicate that. So let's talk a little bit more in depth about NVMe. Why is it important and what's been happening in the industry? So we have SATA flash, SAS flash, and of course NVMe flash. SATA, the protocol is pervasive. In fact, you find those flash devices in your laptops. SAS was designed specifically for the enterprise, but it's going to be an interim use protocol. NVMe will replace it. SAS and SATA protocols were designed for hard disk drives, providing a serial interface and shallow queues. SATA and SAS protocols can't take full advantage of new NAND flash. And that's, of course, the entire reason why NVMe was created. While SAS SSDs have become somewhat popular in the enterprise, performance is greatly hampered by its single queue for accessing I/O and limited queue depth. SATA queue depth is just 32 entries, SAS is 254, and NVMe is 65,000. NVMe fully exploits NAND flash. It supports 65,000 queues, each with a queue depth of 65,000 entries. This massive parallelism gives NVMe its high I/O per second and low latency characteristics. It's also important to point out that you get very good endurance, so very high endurance with your NVMe flash for the amount of writes that you're doing. It's also really important to point out that NVMe SSDs are coming down in price fast. The storage industry has figured out that NVMe's ability to make full use of the NAND SSD will drive up volume. So NVMe is being priced lower than SAS and even down to SATA SSD prices, at least at the smaller drives today. And I think we're going to see this trend continue and continue fast. Some storage vendors have even dropped their SAS product lines or reorganized their companies so they can fully focus on NVMe. And IDC already forecasts that NVMe will have the largest share of the enterprise SSD market by next year. Without some change in shared architecture, however, NVMe drive I/O per second will be stranded inside a server and wasted, and you won't be taking full advantage of what you paid for. Disaggregation and new architectures like composable are the way to fully use the capability of NVMe SSDs. So as I mentioned, a single NVMe drive can deliver an order of magnitude greater I/O per second in throughput than what's possible with SAS and SATA solid-state drives. When you put a dozen of these NVMe devices into a server, and even the latest processor wouldn't be able to drive these devices to anywhere near their capability. And the needs of each application can vary substantially, so determining exactly how many drives are needed in that server is going to be very difficult to do. You're either going to have too much or too little. So NVMe inside the server, you'll find that the configuration will never be optimized. It'll be impossible to use the I/O per second trapped inside that box. In addition, with DAS, or direct attached storage inside your server, you have to purchase compute when you purchase your drives, even when more compute isn't needed. And you have to purchase new drives when you upgrade your compute, even when you could sweat those drives a lot longer. And that's a huge waste. And next, when you look at NVMe inside a storage array, you pay unnecessarily for the capabilities on the controller, such as the hardware RAID and data management, such as the snapshots and replication and business continuous volumes, which are all found in data-intensive applications today. With many orders of magnitude difference in performance and throughput and the much greater loss if not fully utilized, underutilized NVMe flash can waste up to 70% of your investment. think that it is time for a change. It's time to dump DAS for composable infrastructure. Composable infrastructure is next-generation server infrastructure that provides the ability to flexibly create, adapt, deploy, and later redeploy servers using pools of disaggregated, heterogeneous compute, storage, and network fabric. What we do for you at DriveScale is we enable you to program your own logical server, giving you enormous flexibility in how you design it, say from a ratio of 1 compute to 3 drives, or say 1 compute to 300 drives, maybe for infrequently accessed data. You get to optimize so you don't overspend, and then after deployment, you have the flexibility to adapt that configuration. We give you the ability to create your own servers on the fly. So let's take a look at what that would look like. You start with pools of compute and storage. Then using our software, easily create logical servers and clusters, just like that. When you're done with the workload, you can actually put the devices back in the pool if you want to. You can leave your storage at rest and reuse compute. Let's go into a little bit more detail on how the DriveScale composable platform works. On the left are common data-intensive applications and a pool of heterogeneous compute nodes running Linux. Generally, these servers are diskless servers. All they need is a boot drive. And we put a DriveScale server agent on each server. In the center, you have a standard Ethernet network which connects the compute nodes to the heterogeneous storage systems on the right. You can use 10 gig, 100 gig, and soon even 400 gig Ethernet, and that provides more than enough bandwidth to run data traffic. On the right are SAS and NVMe flash drives, as well as SAS hard disk drives, which can be used in simple EBOTs, what are called Ethernet box of drives. Using these types of server and storage devices lowers hardware acquisition costs by more than 40% and makes it possible to increase rack density. We've shown customers we can reduce their data center footprint by 69%. On the storage system, we actually put software, what we call adapter software, to bridge the storage protocol to Ethernet, whether that's NVMe to Ethernet or SAS to Ethernet. Then, using a RESTful API or our GUI, you can design the servers combining the ratio of compute to drives that's needed for the application. One example might be using flash and a high amount of compute for Aerospike. Another might be using a higher amount of storage, mixing hard drives and flash for maybe a Hadoop implementation. Core to the DriveScale architecture is high availability. We have patented load balancing technology that manages traffic across links and moves traffic if a link fails. The DriveScale solution scales seamlessly to over 10,000 compute nodes and over 100,000 drives today, and we know it will scale further. Applications run unchanged, and the DriveScale platform is very high performance. In fact, it's direct attached storage like performance, even at scale. So we're able to maintain performance and high availability from small to very large scale out clusters. So this is true comprehensive composable solution. You choose your preferred hardware, and DriveScale makes it flexible and adaptable to any of your needs. If we look at what you get with DriveScale, it's a number of capabilities. In the center, you see Composer, and that is the orchestration application that makes it possible for you to compose logical servers in high-scale clusters, and it does the management and monitoring. As I mentioned earlier, we have an API and a GUI, and we connect in easily to third-party orchestration platforms. We have cloud-based administration for oversight and audit logs and software upgrades. And then we have our server agents and our adapter software. Everything you see in blue is third-party. So third-party compute nodes, third-party storage systems, and third-party Ethernet fabric, as well as orchestration. What you want to do is be able to get the most out of NVMe without giving anything up. And so there's going to be a number of choices for you. NVMe using iSCSI, which is standard way to deploy today. NVMe over fabrics, which is today pretty much means using RDMA over converged Ethernet. We use the RoCE v2 protocol. And this gives you very high performance and very low latency. But there are some limits on scale today using RDMA. Soon we will be able to provide you with NVMe over TCP. It'll give you near the performance of RDMA, but it scales seamlessly with standard TCP, and we strongly believe in industry standards. And that way you don't have to use any specialized NICs in the servers. We believe NVMe over TCP will meet most use case requirements. So using NVMe over RDMA or straight iSCSI, we do the end-to-end setup. We're completely automated, meaning that we look at how the server is configured and whether it has the RDMA NIC in it. If it does, we automatically configure it. If it doesn't, we will automatically configure iSCSI. So RDMA is interesting. It enables the transfer of data to and from the application memory to computers without involving the processor. That's how you get very low latency and fast data transfer using that protocol. So if that's really important to your application, and you don't yet require massive scale, it's a good way to go. What's interesting, what we've done at DriveScale, is we've made it very easy for you to transition cost effectively from one technology to the next. So you can start with iSCSI today, and it works great, and it's a well-known standard. You can add RDMA using RoCE v2 for high-performance demands, and then you can move to NVMe over TCP. So we give you all of these options and make it easy for you to deploy what you want. We automatically cryptographically secure connections, meaning we cryptographically mount drives to servers over the network, allowing you to have secure multi-tenancy of your applications in a cluster. We automatically load balance storage connections and traffic. And the multipathing we provide gives a self-healing capability on past failures and ability to rebalance workloads seamlessly. Another really cool feature of DriveScale is we can replace a drive without touching hardware, meaning you don't have to physically pull that drive. Let me show you how that works. Through software, you unmount a drive in the cluster and mount a new drive from the pool in seconds. This is a really valuable function when you're running a high-performance application and a drive starts to slow down or show too many errors. You can quickly replace it, copy the data, and continue to run at high performance. So what we provide is the ability to right-size your servers and your clusters from pools of resources. If you look at how the storage systems are designed that are defining themselves as composable, what they're doing is a really important part of the overall picture. They provide, many of the storage vendors provide a storage API, which gives great insight to what the drives are doing. In this circumstance, if you only have the storage API, you have to yourself integrate that with your servers and then determine how you're going to write software to do the load balancing, the HA, and the performance optimization. With DriveScale, we've simply taken care of all that for you. It's compute plus storage plus fabric, supporting your choice of storage system and server vendor, making it very easy and automated for you to deploy the entire configuration and scale that up in a cluster. So you can flexibly compose servers rather than configure storage, automated deployments to very high scale, And then you can actually detach the drives and the storage, leave your data in place, and reuse that compute for another workload if you have workloads that don't run all day, every day. And lots of data-intensive workloads are run once a week or once a month. So the bottom line is we make it easy for you to comprehensively compose your flash or compose slices of flash. We actually slice flash to make it very easy for you to utilize the entire amount of flash storage you've purchased. So we compose compute and flash together. We give you granular control to mix flash slices and hard drives. It's ready to use and automated in real time, meaning you create that configuration when you're ready to deploy. You can tune the configuration as you're ready to deploy or after you deploy. We make it highly available, and with a single click of a button, you can encrypt your data, which is becoming more and more important today with more and more regulations around securing data. So there's so many advantages to using composable and using composable with your NVMe storage. The simplicity of getting rid of server SKU sprawl and cluster sprawl, meaning you can use a single server building block and a single storage system, and then configure out many, many, many variations of logical servers. You design your own ratio of compute to storage with great variability. You can replace failed compute from the drive pool, from the compute pool. You can actually replace a failed drive from the drive pool. And you can upgrade your compute to stay on the compute performance curve and leave drives in place. But one more thing about where the world is going. We truly believe the future is Kubernetes. And DriveScale creates server infrastructure for both bare metal applications and Kubernetes containerized applications. And that leverages any hardware vendor you want to work with, everyone from Dell, Cisco, Western Digital, Seagate, and others. DriveScale and Kubernetes are a perfect fit. Both are designed to deploy and adapt to unpredictable changing workloads. We're actually a certified Red Hat OpenShift partner. Both DriveScale's composable infrastructure and Kubernetes better utilize the resources that are deployed. DriveScale automatically provides persistent storage, including persistent NVMe storage, to Kubernetes pods. And we also provide added visibility for which volumes are connected to which pods. When a server goes offline and Kubernetes instantiates the pod on a new server, the DriveScale storage volume automatically follows. Together, DriveScale and Kubernetes will enable you to design what you need and scale and manage the infrastructure automatically, from the containerized applications to the servers it runs on and the storage it consumes. DriveScale makes low-cost storage both highly available and high performance. We give you the cloud-like agility to create and adapt the infrastructure you need in your data centers or colos. You can eliminate stranded resources with DriveScale, deploy application-ready infrastructure in minutes, disaggregate compute and storage for upgrades, and reduce refresh costs by 44%, over provisioning by up to 70%, and data center footprint by 40%. DriveScale enables the composable data center. Today we compose compute and drives, as well as GPUs and drives, hard disk drives and flash drives. And in the future, when it makes sense, we'll compose FPGAs and memory. We support a number of use cases, from advanced analytics and machine learning, big data analytics, tiered data storage, and all-flash composable storage. And NVMe can be a part of those. And any of these are a great place to start with DriveScale. And that's it for us today. Are there any questions? Yes.
Yeah, great presentation, Denise. We do have a few questions for you here. While I pop up those questions, I'm going to bring up this poll question for the audience. And the question out there, if you look at the slide area, it says, would you like to be one of the first to learn more about the DriveScale solution? I'll just leave that on the screen for everyone out there to respond to. And let's see, first question is from Seth. He's asking, how do you handle rebalancing of clusters if that's needed?
So we actually have, there's two ways to think about that. With DriveScale, you can actually have multiple applications running in the same cluster. You just simply continue to scale out your cluster, and those applications are secure from each other, and then you can easily rebalance resources or add resources to any of the servers or infrastructure being used by any individual application. In terms of just the traffic management that a cluster is using or several applications are using, as I said earlier, we do load balancing of the traffic, of the data traffic, in order to optimize the throughput.
Okay. And then another question here, Kenneth is asking, basically, if you have flash and you have spinning disk, are there performance issues when you mix those, or how do you do you need to tier the storage, or how does that work?
So that's actually a great question. So there are tiered storage applications that can run on the DriveScale platform to tier the storage, and we're seeing a lot more of that these days because people are running or want to run hot, medium, and cold data in the same cluster. And today, they're a little bit stuck in doing that inside a box, and they really can't scale that out seamlessly and uninterrupted off of one cluster. And that way, you can actually have multiple applications, or what's more likely is some workloads, say it's a Hadoop workload or a Cassandra workload, some of the workloads may require more performance and others may require less. And so you're managing your costs by making decisions of combining hard disk drives and NVMe on the same server or the same cluster.
Okay. And then another question here, how do you actually compose your infrastructure? I know you mentioned a GUI or a RESTful API. Is there a DriveScale GUI?
Yes, so there's a DriveScale GUI that can be used, or we have a very rich, deep API that can be used. So it really depends on what you prefer. We can connect into maybe a third-party orchestrator that you also use. And then it's very easy. We have templates. Takes literally 1 to 2 minutes to set up a template or policies to deploy, and you just hit go. You choose the servers, you choose the drives, you choose the type of servers, the type of drives, you set the policy. We automatically choose the components out of the pools and then mount those drives to those servers logically over Ethernet, and then combine those up into high-scale, highly available clusters.
Okay, very nice. Well, it sounds like a really innovative solution that you all have at DriveScale. I think that's all the time we have for the live questions, but there's a number of more technical questions there for you in the queue, if you don't mind responding to those, Denise.
No problem. Thanks, Ed.
Thank you, Denise, for being on the event today, and thank you, DriveScale, for joining us for today's event. If you'd like to learn more about DriveScale, in your handout section right there, you can click View to view the DriveScale solution brief that's available right there that talks about their composable infrastructure solution. Of course, also check out DriveScale.com. And before I introduce our next presenter, I do need to award our first Amazon $500 gift card. That's going out to Kyle Savage from Washington. Congratulations to Kyle from Washington. And now it's my pleasure to introduce Mr. David Ridgway. He is a Senior Manager of Product Marketing at Western Digital. David, are you with us?
Yes, I am.
Thanks for being on the event today. Take it away.
Yeah, good morning, David, and everyone for joining today's EcoCast. During this session, I'm going to share some of my insights on the impact of NVMe on the data center. As I said, my name is Dave Ridgway, and I'm the Product Marketing Manager for Western Digital's NVMe all-flash arrays. Let's start by talking about some of the important role that data continues to play in our personal and professional lives. We live in a world where relationships, our shopping, our jobs, our health, and our safety on the web increasingly depend on data. Data is transformed from being merely a byproduct of digital life to becoming the very engine of our global economy. The data continues to grow at an astronomical rate. New technologies are extracting ever-increasing value from this data. Storage is a fundamental building block to create any value from data. Western Digital has developed and acquired critical IP and technology necessary for end-to-end infrastructures that enable people to capture, preserve, access, and transform their data. Let's start by looking at some of the companies in industries that are aggressively using data to transform their business. What does this mean to business? It means a shift towards more than just delivering operational excellence, to shift towards seamless integration of big data and fast data components and infrastructure to deliver the greatest possible value from data. It's leveraging the fundamental technological building blocks we have developed to find answers to the world's greatest problems. It's enabling advances in artificial intelligence, machine learning, streaming analytics, modeling, and other new purpose-built architectures designed to deliver more precise insights from data. Results are driven by fast data and big data, both of which have an impact on productivity levels and bottom lines. Fast data refers to the data that's in motion, enabling companies to use advanced systems and applications to analyze data instantaneously and make real-time decisions that have direct and immediate impact on business interactions, observation, and most importantly, improving business productivity. It's a goal of many projects to identify actionable insights from big and fast data. To gain the ability to react to life as it happens, your infrastructure plays a critical role in being able to develop new programs to process data with near or actual real-time response time. Let's explore some of the ways in which fast data and big data are making an impact on the IT infrastructure. Big data and fast data provide timely insights and real-time monitoring for forecasting events that could potentially impact business performance. The ability to access this type of data is extremely important in improving processes and reducing risk. One powerful illustration is the time value of data is something like Waze, where the mobile navigation tool can predict potential routes based on the current speeds of many drivers ahead of us. Workload acceleration is another critical driver. Big data and fast data applications solve problems by utilizing advanced storage technology to help optimize results. With data at your fingertips, IT departments can help business leaders connect the dots and interpret the statistics necessary to make informed decisions. And data-centric management. Big data and fast data provide a tangible platform for employees to evaluate and improve their job performance and efficiency through timely updates and streamlined analytics. IT professionals can use both forms of data to teach employees about business analytics and evaluate the quality of their work performance. Non-volatile memory Express, or NVMe, is the new protocol and command set to connect non-volatile memory, flash, and persistent memory devices directly to the host across the peripheral component interconnect bus. This is the PCIe bus. NVMe speeds up your data center by providing direct memory access to storage, bringing the data closer to the compute resources that need it. Provide multiple parallel low latency I/O queues to transfer data from the NVMe storage device to the applications and workloads that access it, and basically utilizes higher PCIe bandwidth links than SAS and SATA. By eliminating the SAS and SATA protocols, we can reduce the storage stack overhead, freeing up CPU cycles for use by the applications. These benefits, combined with the ability of non-volatile memory express SSDs from vendors like Western Digital, is rapidly enabling NVMe to become the dominant storage solution in fast data applications in the data center. At the heart of any effective system is a well-chosen storage platform. N-Series 100% NVMe Enterprise Class All-Flash Array. This is a Western Digital product that the N-Series extends the Western Digital IntelliFlash product line, which already offers super fast high-density all-flash arrays. With NVMe built in, the N-Series offers even faster performance, value, and scale. It offers 50% lower latency. These applications can be accelerated, cutting data analysis time in half. 1/3 lower TCO built on top of the enterprise class software features for data reduction. These can shrink storage footprints, lowering power consumption and reducing the overall TCO of storage. And they also this arrays offer 2x more consolidation. Modern software architectures provide both block and file protocol access, consolidating workloads for specific needs into one array. The N-Series comes in two versions, the 5200 series for read-intensive workloads and the 5800 for mixed read-write intensive workloads, providing basically 8 capacity options ranging from 20 terabytes to 180 terabytes of raw capacity in basically a 2U form factor. The performance and density improvements from NVMe increase value and unlock new use cases for N-Series all-flash arrays. Today's interest in NVMe is growing at an explosive rate due to a couple factors. Application demand. This is to provide real-time interactions and experiences to end users. Applications need faster storage that can read and write the tsunami of data very quickly. Legacy storage technologies cannot keep up with the performance demands imposed by new application environments. NVMe provides, in addition to direct access to flash memory as low as 250 microseconds, it also provides basically one flash platform with any workload for enterprise resiliency and availability. It also provides basically faster access to flash for data services and data reduction. Most demanding workloads demand IntelliFlash NVMe all-flash array. The N-Series enterprise storage arrays enable organizations to transform their business by accelerating their mission-critical applications and performance-oriented real-time machine learning, artificial intelligence, and deep analytic applications. These workloads can be categorized into several groups. In addition, these workloads support database applications as well, including online transaction processes and DB analytics acceleration. And most importantly, DevOps and scientific applications can also be used. Artificial intelligence and machine learning are no longer buzzwords in the industry. With fast processing capability, memory speed, persistent storage, and high-speed interconnects between them, we are at the cusp of making organizations thrive in their data centers. Western Digital provides a whole portfolio of NVMe products. We call it our silicon to systems innovation. In addition to developing the NAND flash memory devices ourselves and the controllers that actually access and perform the NVMe protocol functions, we put these and package these into our UltraStar data center series enterprise class SSDs. These come in PCIe as well as 2.5-inch form factors. We also have a series of memory expansion drives, NVMe storage servers. We have composable NVMe fabric devices and enclosures, and of course the N-Series product line, which I just discussed today. You can find more about each of these products on Western Digital's website at www.wc.com/products. And again, thank you for joining me today on this NVMe EcoCast.
Great presentation, David. Thank you for being on the event. We do have some questions here for you from the audience. And while I ask you those questions, I'm going to pop up this poll question on the screen. And it says, would you like to be one of the first to learn more about the Western Digital solution that you were just presented to on the event today? So I'll just leave that up for the audience to answer. And let's see, David. First question here that came in, they're asking about how do NVMe arrays fit into an existing data center? Do you have to rip and replace the storage you have, or can you add to that?
A good question. No, these devices are basically SAN-attached devices. They come in both SAN and NAS configurations, so you can attach them directly to both Ethernet networks at 10 and 40 gigabit Ethernet, or fiber channel networks at 8 and 16 gigabit fiber channel. So each one of the arrays is an enterprise class device with 2 controllers. Each controller has the ability to connect to the Ethernet as well as the fiber channel networks. So no rip and replace.
Very nice. Very nice. Okay. Another question here. How was the IntelliFlash software optimized for NVMe solid-state drives? Did you do something to change it to make it NVMe compatible or perform at that level that's needed?
Yes, the NVMe protocol is basically a direct connect over PCIe. So we basically are now communicating directly over the PCIe bus to the NVMe fabric. We've basically upgraded the architecture to allow and support direct access to NVMe. In addition to that, we basically leverage the entire software feature set that we had with the IntelliFlash product line and are able to deploy all of the same enterprise class features on top of NVMe.
Okay, excellent, excellent. And then another question, how will the N-Series support, or will the N-Series support NVMe over Fabric?
In the future, yes. Right now, these devices are basically direct connections to both Ethernet and fiber channel. As we see the, let's call it the maturity of the NVMe over Fabric standard evolving, we will certainly provide those host interface connections as well. But today, we're trying to be more consistent and, let's say, available for customers who don't want to do a host side upgrade to an emerging host interface standard for RDMA or other protocols. We're planning to use this technology over standard interface connections today.
Okay, all right. Well, very nice. Well, that's all the questions we have here live on the event, but great presentation. I really appreciate you being on. Thanks, David.
Thank you.
For more information on the Western Digital IntelliFlash N-Series storage arrays, make sure you check out the handout that's available in your console right there next to the questions and answers box. Just click on handouts, and you can click on Western Digital after that, and that'll bring up the very nice data sheet that I'm looking at right now on the enterprise NVMe flash arrays from Western Digital with all the details. All right, if you haven't answered that poll question, I appreciate you answering it. I'm going to pop up another poll question while I announce our final 2 gift cards on the event today. So the question on the screen is, what's your time frame for updating your existing or selecting new storage solutions like those you've seen on the event today? All right, our first Amazon $500 gift card winner earlier today was Kyle Savage from Washington. We've got 2 more. So the next one is Jesse Packett from New Hampshire. Congratulations, Jesse Packett from New Hampshire. And the third and final gift card is going out to Andrew Hendricks from California. Congratulations to Andrew Hendricks from California. All right, if you haven't answered that poll question, I appreciate you getting your response in because we are about to wrap up today's event. All right, before we go, I want to quickly remind you to check out the Actual Tech Media 10 on Tech podcast. It's available over in the iTunes store. We do short interviews with some of the most innovative people in enterprise technology. You can subscribe and learn about some really cool enterprise tech on the podcast. So make sure you check it out. I also want to remind you to check out events.actualtechmedia.com. This is where we post all of our upcoming events, the MegaCast and EcoCast event series. You can register for all of the events at that site. In fact, we have an upcoming event next week, February 13th. It is the Data Protection, Disaster Recovery as a Service, and Disaster Recovery MegaCast. It's going to be a big event, so make sure you join us on that event. I look forward to seeing you there. And if you've watched this event and you're a potential sponsor of our virtual events, feel free to reach out to sales@actualtechmedia.com to contact us about presenting. And with that, we've reached the end of today's Storage, Flash, and NVMe Storage Optimization EcoCast event. Thank you so much for taking time out of your day to join us. I look forward to seeing you on the next event. Have a great day. Bye-bye.